This is problem number 66 from chapter 2, 7th edition of Resnick Halliday. A rock is dropped from rest into a well. If the sound of the splash is heard 2.4 seconds later, how far below the top of the well is the surface of the water? The speed of sound in air is given to be 336 meters per second. If the travel time for the sound is neglected, what percentage error is introduced when depth of the well is calculated? So for this question, I have drawn a rough picture of well here. So let us say that this is our ground level. Okay, this over here is our ground level. A person is standing, he drops a rock. This distance is y. So if we fix our origin at the ground level, then this distance is minus y, right? I'm just assuming that y is greater than 0 so that we don't have to worry about the signs later. So from the equation of motion, we know that the distance traveled minus y would be equal to initial velocity times time. Initial velocity over here is 0 plus half at square, but a is actually g, which is minus 9.80 meters per second square, right? So we have minus half g times t fall square. So we are saying that the stone falls for tf second, and from here we can find out what is tf. So we get tf as equal to 2y over g square root, right? Now the sound, as soon as the stone comes in contact with the water, it makes a splash, and that splash travels upwards with a positive velocity, which is 336 meters per second, and we are assuming that this sound velocity is not affected by gravity at all. So we have the change in distance, because this is 0, so it is 0 minus y, so it becomes plus y. This should be equal to the distance traveled by velocity of sound times time taken by the sound. So we get from here time of sound travel to be equal to y over vs, and now we have been given that tf plus ts is equal to some total time t, which is actually equal to 2.40 seconds. So we can, now we know everything in terms of what we have to solve, so we can simply create an equation and solve this, right? So we have square root of 2y over g plus y by vs should be equal to t, implies that 2y by g should be equal to t minus y by vs square. So it is t square plus y square by vs square minus 2 times y times t by vs, and now we can change this into a quadratic equation in y, and we can solve for y, right? So we have so we have 1 by vs square times y square. This minus 2y by g goes to the other side, so becomes minus 2 times 1 by g plus t by vs y plus t square is equal to 0, right? and we know everything now. We know Vs, we know 1 by G, we know the value of T. So if you substitute these values and solve for the value of y, you will get two values. The two values would be so we get two values as y is equal to 26.4 meters, and I'm only writing to correct to three significant figures. So and another value we get y is equal to 26,400 meters. Now obviously this value is absolutely wrong, because if this value is taken to be true, then the time taken by the sound also takes more than 2.4 seconds. So we have to reject this value, and the correct answer in this case is that the well is actually 26.4 meters deep, and we are done.